Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be introducing the topic of electrochemistry. And if you want to understand electrochemistry really well, you have to understand oxidation reduction reactions. So we're going to do a little bit of a review from some of our old videos on oxidation reduction reactions, starting out with reviewing basically what an oxidation number is. Okay. So if you remember when we did oxidation reduction, we talked about oxidation numbers and we always assigned oxygen as -2 and hydrogen as +1, and then we figured out the rest. Okay, so in this example, okay, if I was going to break down carbon dioxide, now I know this is a molecular compound, it's not ionic. Oxidation numbers is just the bookkeeping of electrons, okay? And if I were to break down the carbon dioxide, there's one carbon and two oxygens. And if I assign oxygen as a -2 to each of them, then what does carbon have to be for this whole thing to be neutral? Because there's nothing in the upper right-hand corner indicating a charge. Well, if you answered that the oxidation number for carbon would be a +4, you are correct, okay? And that's how we calculate oxidation numbers. We assign oxygen and hydrogen their appropriate oxidation numbers, and then we figure out the other elements as needed, okay? Let's take a look at one more example, and this is going to be hypochlorous acid, okay? Now we're going to assign the oxygen first as a -2, okay? Then the hydrogen as a +1, okay? So what does that leave us as with the chlorine, okay? Well, if this whole thing's going to be neutral, then a +1 with another +1 will cancel out that -2 charge. So the oxidation states are +1, +1, and -2 respectively, okay? Now, what happens if I had this compound? Well, I'm going to break this down into its elements. So H, Cl, and two O's. So -2, -2, +1. Well, what does this have to be now? Okay, well, to equal out the -4, to cancel it out, this would have to be a +3 with the +1. So the positive part would be +4, the negative part would be a -4, so everything cancels out. So as you can see, as we start to add oxygens, the oxidation state on the chlorine is starting to increase. And if we did that a couple more times, like, I'm sorry, that's supposed to be chlorine there. This is going to end up looking like this with 3 oxygens, -2, -2, -2 with a +1. Well, now this has to be a +5. To cancel out this -6 with a +1, that has to be +5. And then finally what we have perchloric acids. We got hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. And really, you will see that each of these oxygens being a -2, all that's doing to the chlorine here is increasing the oxidation state, okay? And as that oxidation state increases, so does the strength of the acid, okay? So both of these are actually weak acids, where both of these are actually strong acids, and it's due to that electron drift of being able to pull the electrons off of the hydrogen to protonate it, okay? Now, all of that is just kind of like review, okay? But I just wanted to come back and review the oxidation numbers. I related it a little bit to the acid-base work that we've been doing recently, but really I just wanted to review these oxidation numbers with you before we go into what an oxidation reduction reaction looks like. Okay, so let me erase all of this review on oxidation numbers. And let's dive in deep, okay, or maybe not very deep, just the really beginning because we're introducing the topic on oxidation reduction reactions, okay? So let's say I have this synthesis reaction between lithium and oxygen to form lithium oxide. Now, if I'm going to balance this out, okay, I do believe I'm going to have to put if this is lithium oxide, if I have 2 oxygens, I need to have 2 oxygens on this side. That gives me 4 lithiums. So it's going to be 4, 1, 2 as far as a balanced chemical reaction. Now, what I'm going to do is I'm going to come back in here and I'm going to assign oxidation numbers. When elements are by themselves, okay, they are neutral. Okay, they are not charged. Okay, so this is lithium. There's no other element present. It's zero. It's neutral. Same thing for oxygen. No other element is present. It's zero. And you might be saying, well, Mr. Heffel, I thought you said the oxidation number on oxygen is -2. Only when it's in a compound. Okay, so the oxygen here is by itself, so it's going to be neutral. Now, oxygen over here is with the lithium, so it's going to be a -2 here. And if I was just to break down this lithium oxide to look like this, I'm sorry, let's try that one more time. 2 lithiums, 1 oxygen. If the lithium's a -2, if the oxygen is -2, each of the lithiums are going to have to be +1s. Okay, so +1 on the lithium, okay, -2 on the oxygen. Now, this compound is ionic. It's not molecular like the other. So there are charges and oxidation states. If it was molecular, meaning 2 nonmetals, they would only be oxidation states. Okay, but if it's an ionic compound, the oxidation states and the charges are the same thing. Okay, so we have this oxidation reduction reaction. And the one thing we need to know about oxidation is these are the elements that are going to increase in oxidation state. So what we need to do is we need to look at either the lithium or the oxygen and say, hey, which of the oxidation states are going up? Because if it's going up, that means it's being oxidized or going through the process of oxidation. And when we look, we see that the lithium is going from 0 to +1. That is the one that's going up. Okay, now what I want to do is I want to write a half reaction, okay? Because a lithium that's neutral is not the same thing that is a lithium as a +1. So if I'm going to make this equal out, I'm going to put an electron on the right-hand side, because an electron and a lithium +1 will equal the lithium that's neutral. Now what I'm going to end up doing is I'm going to multiply this equation by 4, because there's 4 of them in the original equation. So this is going to look something like this. If it took one electron to make 1 lithium +1 to be neutral, then it's going to take 4, right, electrons to make 4 lithium ions to be neutral. Okay, and the best way I can show this example of what's going on here is that the lithium's actually losing electrons. So I have this cap on my marker, and the cap is going to represent an electron. And basically on the left-hand side of the reaction, lithium is neutral, right? But if we pull the electron off of it, okay, now the lithium, okay, is a +1 ion, and here's the electron. And all we're doing from here to here is multiplying everything by 4, because it's happening 4 times to lithium. Okay, so we say that lithium is going through the process of oxidation, okay, or it's being oxidized. And if it's being oxidized, we also will call it a reducing agent. The chemistry gods were not nice with this vocabulary word, because it's kind of like the opposite of this. So I also want to make sure that I cover some of the vocabulary. Okay, so lithium is going through the process of oxidation. It's being oxidized, but it's also referred to as the reducing agent, because it's the thing that's causing reduction for the other element. Because if you're going to have oxidation, you got to have reduction. And basically what oxidation is, it's really the thing that's losing the electrons. The electrons are popping off the lithium, okay, and they're going to go someplace else, okay? Well, where's it going to go? It's going to go to the other element that's going through the other process, which we call reduction. So if you have oxidation, you're going to have something that's going through the process of reduction. If you have something that's losing electrons, you're going to have something else that is gaining the electrons, okay? So let's take a look at the thing that goes down in oxidation state. As you can see, the oxygen is going from 0 to -2. So I'm going to go ahead and write that for one of these, 0 to -2. Now, this is not a good equation because an oxygen that's neutral is not equal to an oxygen that's -2. So what has to happen to this oxygen is it has to gain 2 electrons, okay? So the oxygen plus 2 electrons will make an oxygen that's -2, okay? Well, this is happening 2 times in the original equation. So I'm going to come down here and I'm going to multiply it by 2. Now, when you're multiplying by 2 here, just like I multiplied by 4, it's a little bit different for this one because we're dealing with something that's diatomic when it's neutral. So when you do the multiplication, you got to be a little bit careful, okay? So whenever it's neutral, okay, it gets the little 2 here because it's diatomic, okay? If it has an oxidation state, it will always be a coefficient, okay? Only the diatomics, when neutral, will get a little 2 here. So when you do the multiplication, you just got to be careful with your diatomic elements, okay? Now the electrons, they're going to be multiplied by 2 as well. And the same thing over here, it's going to be multiplied by 2 as well. Okay, so what we have here is we have an oxygen that's gaining 2 electrons, okay, to form the -2, and then we're just multiplying that by 2. It's happening 2 times in this original equation. And what you end up finding out is that the electrons that are lost in the oxidation process has to be equal to the same number of electrons that are gained in the reduction reaction. So if you're going to have oxidation, if you're going to have something that's losing electrons, you got to have reduction, something that's gaining the electrons. And then when you gain electrons, your oxidation is going to decrease, okay? Because electrons are negative. If you take them in, okay, that's going to decrease your oxidation state, okay? Whereas if you're losing the electrons, if they're being pulled off of you, okay, your oxidation state's going to go up, okay, because you're losing the electrons, okay? So as far as vocabulary here for the reduction, okay, we're saying that this is going through the process of reduction, okay, or it's being reduced, and then that chemical is also called the oxidizing agent. And that's where I said before the chemistry gods were not nice to you, okay, because it's kind of like saying the opposite, okay? So if you're going through the process of reduction, you're considered the oxidizing agent because you're the thing that's causing the other thing to be oxidized, okay? And in reduction, in the end, what's happening is that you're gaining electrons. So in oxidation, you're losing the electrons, and then in reduction, you're gaining electrons. So really, what an oxidation reduction reaction really is, quite simply, is a transfer of electrons. You have something that's losing the electrons, and you have something else that's gaining the electrons. And we have this mnemonic device to help you memorize everything, and it's called oil rig. And what it stands for is oxidation is losing the electrons, oxidation is losing the electrons, and rig, which stands for reduction, is gaining the electrons. Reduction is gaining the electrons. So hopefully all of this helps out, okay? As we move further in electrochemistry, what we're going to do is we're going to find out how can we separate the oxidation and reduction part, and as the electrons are lost and moved over to the other cell, can we tap into that transfer of electrons? Because that's basically what electricity is, or what we get out of a battery. So oxidation reduction reactions are very, very important. This transfer of electrons, if we can tap into that flow of electrons, it can help power things, you know, with the use of these batteries, okay? So if you found this information helpful, please give it a like and subscribe. When you add that comment, it really does help push this information out to other students that are interested in learning chemistry.